Neighborhood 6, and we did our presentation on what factors influence Airbnb prices in Tokyo. I'm Lilala.
Trevor.
This is your. These are good rules, and this is our table of contents, consisting of the introduction, data cleaning, EDA, results, and conclusion. So first I'll start off with the introduction and background. So first, Airbnb is an online global platform for travelers looking to travel to various countries or locations. It has more than 150 million worldwide users and 7 million listings in over 220 countries. How it works is that property owners of homes, single rooms, or apartments can rent out their properties to travelers for a price. And the reason behind its popularity is because both renters and owners can benefit from the experience. So in other words, the owners can earn rental money by renting out their property, and travelers can save up money to spend on other things like dining or traveling to other places. So Airbnb is also very popular among tourists traveling in Tokyo. It has the 19th largest Airbnb market in the world with a median occupancy rate of 92% and 18,493 active Airbnb listings as of March this year. So why predict Airbnb prices in Tokyo? So our purpose is to help Airbnb users to find suitable accommodations in Tokyo so they can find the right room types for prices they find are affordable. And this is important because first, Japan is an extremely popular tourist destination with visitors projected to surpass 40 million this year. And second, because high tourism satisfaction can also support the Japanese economy. So we know that tourism can generate revenue, support local businesses, and create employment opportunities in Japan. So our goal through this project is to predict the possible factors that affect Airbnb prices in Tokyo to gain insight on which areas and room types, etc., will be more expensive or cheap.
Next, I'll talk about data cleaning and reprocessing. Our data set was from inside Airbnb, which scrapes their data from Airbnb, and it was collected on March 23rd this year, which is recent, and it has the quarterly data, like 3 months, and the data set size is like we have 22,000. Factors include neighborhood, location, room type, reviews. We excluded some data because we have the same price, and we also strengthened some data so to prevent extreme skewing, which resulted in 20,000. And we also anonymized the data in order to comply with Airbnb's privacy policy. Identifiers such as ID, name, host dropped. And the exact locations were obfuscated, but not enough to affect the accuracy of the data. And the dates, the master review dates were not completed. Also dropped some useless information because neighborhood group does not contain any data, and the license is not necessary for a server. And the last review values were converted to simple numerical values from the street from other dates. So instance, we had some missing values in the values related to reviews. It means they have 0 reviews. So once since last review was set to someone just older than the listing with the oldest review, and reviews per month was just set to 0. Since some listings were extremely highly priced, and this made the distribution strongly skewed to the right. So we log transformed the prices, which made data look almost symmetric. Some visualizations to check distributions, selected variables. The spike here is the sentinel. We set to capture listings with no reviews, which can be used by tree models. Matrix shows there are market linearity, and long ones, they listings get 5 viewer monthly reviews, which is consistent with lower booking turnover. Price is not showing any significant simple linear combination, so we likely need more non-linear models to make more accurate and meaningful predictions. So the chart showing the block transfer price distribution, and out of the entire homes, apartments being the most expensive, shared rooms being the cheapest. It also highlights the possible outlier in possible mattresses, which are classified as entire homes inflating the prices. We have some categorical variables in our data set, mainly room type and neighborhood. We use the one-hot encoder to split them into new columns and to contain binary values, indicating if each feature is a certain room type, and if they are in certain neighborhoods or not.
And then we get some results. First, we use like simple linear regression to fit in the first model, and we can see from this graph that the model tends to underestimate prices at the higher end. However, it captures the general trend, but it is not like completely accurate, especially for higher prices. And then we check the minority assumptions. We can see it is generally central skewed, so the general trend is right, but however, there's still some insurance here. So we then check the ratio versus predicted. It is fairly even distributed across the range of predicted values, and there's no adverse patterns or trends. And to see the linear relationship, there's no clear pattern that suggests a curve. And all the plots are generally centered around the 0 line. And it is the spread of the residuals appears to be constant across the range of predicted values, and there is no U-shaped pattern or other symmetric variations. And then we fit in the Lasso regression. First is the average CV and ICV. We can see from this picture that the balance point of the model is alpha equals to 0, and within a range of lower alpha values, MSE changes little, which means it is stable. But here, it rapidly changed, and this means it is a unstable one when the alpha increases. And then we check the Lasso path. The red dashed line here, it is the best performed alpha value, and all values get closer to 0 as alpha value increases. And last, we get Lasso selected features. We can see from this graph that the most important features are the largest positive coefficients up here. And the less important features have relatively large positive coefficients, and the negatively impacted features have smaller negative coefficients. And last, we fit in XGBoost. We can see from this feature importance that the ranking is ranked from the highest to the lowest importance score. And for feature selection, the features with the greatest impact on model prediction can be identified, facilitating feature selecting and optimization, which means, like for this, we can see the group type and the location is equally ranked. So if we want to get the most important facts, we can use the form like location plus room type. And we can get conclusions that room type being private room's entire home apart, shared room, and being located in Otaku, Minatoku, Taitoku, and Shinjuku are the main influencers of the model prediction. Then we make comparison for the three models. The XGBoost has significantly better R-squared and lesser RMSE, so we can say that the XGBoost fit in the model best. And for lasso and simple linear regression, they have similar R-squared for training and test data, so it shows that this did not handle nonlinear patterns well. And why XGBoost fitting well? Because it's like a tree model, so it is more stable for the nonlinear data sets.
Okay, so the conclusion. So back to our object. Our object was to predict the possible factors that affect Airbnb prices in Tokyo to gain insight on which areas and room types in Tokyo will be more expensive or cheap. And based on our data analysis, so basically we used linear regression and lasso and XGBoost. And among these data sets, we find out that the XGBoost provides the highest predictive accuracy, and this shows that the XGBoost was the better at handling the complex relationship between the factors like room type, location, or accommodation type, and the linear models couldn't fully capture it. Also, the strongest factor was the room types and neighborhood, and the top neighborhood was being Otaku, Minatoku, Kaitoku, and Shinjuku. And Otaku is kind of a special case because it might seem like a less popular location, but it's actually near the Haneda airport, so it's possible factors to be included. Oh, and about the data table, the red box, you can see that our R-square in XGBoost is the highest, and the root mean, the square error is the less, which means it has the highest accuracy, less error. And then our research is that the main factors that include the price of the Airbnb in Tokyo or type of the room, is it private or shared or hotel, the entire thing, and is it like a type of accommodation, like is it full house or apartment, studio, or is it guest house? And lastly, it was the location, is it urban-based or suburb, neighborhood, or there is attraction nearby. So based on our findings, we set a real-life implication. So for the visitors in Tokyo, we could say that choosing the location outside of the popular neighborhood can cut the accommodation costs. And secondly, choosing the shared room and avoid the private room, which influence the price the most. And then for the host-wise,
we could say that we can maximize the revenue using the data set can insight to set a competitive price and maximize the revenue. And then lastly, in the perspective of the platform, which is Airbnb or other platform, we could say that the data sets can improve the dynamic pricing algorithms with more accuracy and machine learning based recommendations. This could be the one possible project we could do it in the future. And lastly, there's a study limitation. So first of all, there's a missing data set, the date data. The data set did not include the date information, which is a major factor in price variation, such as holidays or peak season. And this limits our ability to predict dynamic pricing. Also second, there's an insufficient data information. The data set did not have enough price over time, which restricts our ability to include the holiday seasons and consideration. And there's a data skewness. The data set had extreme outlier, which might have affected model irregularness. This could include the night limitation or the price and something like this. And lastly, the categorical variables and nonlinear patterns was shown. And the linear models like the basic linear regression model and Maxwell do not have handled the nonlinear patterns well. And this is our reference. Thank you.
Yes, thank you very much. Questions, comments? Unlike the previous prediction problem for life expectancy, group 5 showed extremely high accuracy with R squared being closer to 0.8. And for your data set, which is I think very typical for typical data set, we often use in practice to establish a model with R squared close to 0.3 is not a surprise because the data set is pretty messy. And you mentioned the limitations that there are many important information affecting the price, such as holiday, the date are very important information. So, from the customer's perspective, or what's the number one advice you will give from your analysis?
To share rooms and take the rooms outside of the popular areas. To
share rooms?
Yeah, so shared rooms are also cheaper because they cost, they have less hands per listing, so it's a more efficient use of space, so it can cut the cost of the accommodation.
Share rooms in some unpopular area. But these advice, I think we can give these general advice without a detailed data analysis. Share room. Usually sharing a room, I think, much cheaper than spend time in hotel. So, do you have any other particular advice resulting from the analysis? From both the perspective of the customers and the owners of the facility.
Sometimes room type is a single room and shared room, and which we can know from our experience easily. So our most focused on the location. Like the private loan is like obviously the most expensive one.
What loan is most expensive?
Private loan.
Private loan.
Yeah, and we can choose like the loan type according to your cost expectation and plus the location. And we can easily see from here that being located in Otaku and Minatoku and Taitoku, Shinjuku are the most important, or in other words, maybe the expensive one. And so when you choose, you can like get out of these locations and maybe you can get the cheaper one.
Okay, so you made location-specific comparison. Okay, very good. So any other questions or comments? If not, let's thank the presenters again. Thank you very much.